Simplified are a set of guys who makes it looks easy. Your number one learning channel. Ooh, ooh.
Hello,
Hello, sir.
how are you doing today?
I'm getting you.
I'm very good. The academic struggle is serious, ne? It's real.
Yes.
I laugh because at that moment when it's happening, it's real life too. And remember, if we're to go few months back and we remember the New Year resolutions, it was still nice when we were committing ourselves. Sorry, you know what? We're gonna do this. We're gonna be on top of things. We'll be ahead of teachers. But now the time is not there, bruh.
Ish.
Mara, it's fine. We'll fight the year. Today, I don't have anything prepared. I just decided, Hori, you choose the topic, and then we'll just go with the flow.
I wanted to start with circle geometry.
Oh, okay.
Yeah.
I remember last time we were doing analytical geometry because we were getting to approach that part. So far, okay, I don't have a problem. We can go to it, but before we go to it, I'm gonna ask how far do you stand with analytical geometry so far? Did you manage to do something from last time, from our previous meeting?
Oh yes.
Is there some confidence here now which you feel like now I got this?
I think with a little bit more practice, it would be fine. But for now, we can start with circle geometry.
So, so we're canceling Mr. Miyagi's works on, works off, and we're jumping to the karate before.
Yes. Ish.
Okay, okay. You know what? I don't, I don't know what's the rush, but I mean, let me. You know, the point is not to rush these things. The point is to cover each chapter with confidence before you move to the next one. That's the secret. But people are used to putting pressure on the night of perhaps having the exam the following day or having some commitment, and you feel like as long as I know how it's done, I will practice on the day when it's needed. Sometimes the way to go, sometimes ish.
Oh yes.
Okay, let me give you a try. Let me give you a trial scenario, just to prove a point if we should have to go back or not. I'm not gonna talk about proving any theorem for today. We're gonna have a special day for that. Hence, I say with proving theorems, at some point it's like studying um, a theoretical subject, because sometimes some students may struggle to make sense out of proving a theorem, such that you end up um, you end up just showing how it's done because you could have memorized exactly how the theorem is from the page. So some people, they get to that point where they memorize the theorems. So you would know, like, I have to prove about 9 theorems at an exam, so I'd memorize them. But when we get a chance, I'll try to explain without having to memorize as such. Okay, look at the structure. The structure, it has triangle inside, a lot of triangles, like a lot, and different types of shapes, which you might know some, you might not know some, based on the theorems that I say we talk about. I will find out, but I know most of these things, they are new to you, ne? When you look at the structure, I always say you must try to look at the structure before you look at any question, and try to see from the structure, if there were no questions that had to be asked, what information can you extract yourself from the diagram? So what do you see from the diagram? Or we can quickly read the information. In the diagram below, df, yeah, df is a diameter of the circle with center O. Chord eg intersects df at h, such that df is perpendicular to eg. Chord ef and gf are drawn, as we see, and then we have angle egf is equals to 55 degrees. Do you comprehend what is going on here before we say anything?
I understand it a little bit, but not fully.
Okay, so uh, if there's one outstanding shape inside this circle, if there's one outstanding shape, it should be something like this. I don't know if you this one that goes like this.
Oh my.
I think that shape that touches all the sides of the circle, it should be the one that is outstanding for us so far. We're gonna talk about the shape soon. Have you seen this shape before? Or is it the first time you see it? Or is it familiar? This shape is so special.
Oh, I haven't.
Uh, okay. Before I multitask, let me just reply. Let me reply to a text quick. Um, Multitasking is not my thing. I'm gonna end up texting mathematical stuff here. A lot of people they were ignoring. I thought probably because it's Mampara week this week. I thought everyone just is not in a mood of like having a lesson or something. Now people are like coming back like hey and hey. Now I don't think from here we're gonna continue with lessons. We have to arrange for tomorrow.
Oh,
So you see, Hori, everywhere students are the same.
yes.
You're not the only lazy. You're not the only lazy person, but hey, it's just life, man. Okay, you know what? I'm gonna come with the theorems ka one one ka order. Um, we're gonna explain the theorems. I'm thinking, let me approach it like this. I'm looking at something. Let's let's put each other on hot water, and then we'll see if it would be just a revision of if we remember some of the rules from the previous year. You're gonna try to attempt it. If it doesn't work, and then we're gonna approach it together, whichever one we are doing. So now look at the situation we have. From all the information that we have, um, already you can pick up some of the sides that could be equal. Like for instance,
D
looking at
E N
anything
E
that
O.
A E
D E
D E D E and what?
E O.
Why do you say D E and E O are equal? What's the reason for that? Remember, you must have a reason for everything. So
Because
let me take
it's kind of perpendicular.
so you're saying this and this,
Yes.
but you need a valid reason for it. It may look With your eyes, it may look equal, but what is the analytical geometry reason that you say they should be equal?
I would usually do like congruency.
Ah, yes, I get that because the angles, like for now, you have two angles that are equal, which is probably H2 and H3. But from H2 and H3, what else do you have that you are sure that is equal?
Maybe G.
EH is the line that is common, yes.
Oh yes.
But you have two things only.
Are we looking at triangle EDO?
Yes, to prove your ED being equals to OE. We are
Um,
improvising right now. Before we answer any question, we're just trying to figure out what information do we have ourselves before we can try to attempt anything. Because that's the confidence we get before we answer a question. So you you think DE is equals to OE. So I'm like, what's the valid proof? So you said you would do congruency, which is another way of like um, going like I know there are different ways of doing things in mathematics, but in this regard, for you to prove congruence, it's gonna be hard because you only have two things really. It's just H2 and H3 being 90 degrees and EH being common. You can't say anything regarding angle E1 and E2 because you're not sure how can they be equal. You can't say anything regarding O1 and angle D. You can't say anything regarding the sides also. But there is something you can say. You see, you are 100% sure that OD is equals to OE. Why? Because they are radiuses, and you know
mm,
by confidence that radiuses are equal. So you know by default, also this one is also equals to them because it is also a radius. You are not guessing. You are confident. You are not proving congruence or anything. It's something which you can visibly see. Anyone can see it out there. That's one of the outstanding things that we see so far. Over. The other one that we see that is outstanding is the fact that obviously H1, H2, H3, and H4 they are all 90 degrees, which is good for us. When we see now, we know that in terms of lines that are equal, now they give us isosceles triangle. So we can relate some of the angles that are equal already just for these sides to be equal. It means this angle will be equals to that angle, and also this angle will be equals to that angle. That's now adding information before we answer any question. Now we are getting somewhere. Somehow we know okay sharp. If we can get this one and get this one will lead us to this. But enough with that. I think the question that we have, we don't have to stress about number A because number A they just want us to get the value of angle D. Do you think that would be a problem?
not
Now,
necessarily.
is that part where we know that every answer is in our eyes, angles are just playing hide and seek with us, and the only way to unlock the hide and seek is to remember the rule. What is the reason for me to say this?
I'm not sure.
Uh,
Yeah.
so
Mm.
we say that um, when angles are formed by a chord like that, when angles are formed by a chord like that, such that that chord suspend an angle that goes there and comes to the same point, and also lives from the same point and goes from there and also lands there, it creates angles that are equal, which is this angle as well as this angle. They happen to be equal exactly. And then the reason for that, you will say, so this is how you put it. And can you remember, we are doing circle geometry which needs statement all the time. We need statement as well as the reason why we are saying it. Hence I said, you can't just say DE and OE are equal because you don't have evidence for that at all. And to try to find that evidence, you are wasting your time. You are in an exam. Some of the things are just 2 marks, some of the things are just 3 marks. So you're just trying to find the fastest one. So this is a theorem. There's a way we can prove this theorem. Hence I said we're going to talk about theorems because now I feel like we are jumping into the ocean without actually doing the things. So I'm just showing you there are things which you have to come order, but there's a way which it's part of the theorems which even if you don't apply it, you must know how to work it out such that why do we say these angles end up being equal if you have this scenario like that. It's one of the things which you must practice how to do. But now, okay, sharp. So the reason with this one, because it's exactly 2 marks, assumption that you already know the theorem. So it would be that angle D2 will also be equals to 55 degrees, because the rule says if they are formed by the same segment, they are the equal. So vele that's the reason angles in the same segment, 2 marks, that's it. But that theorem is something which we need to go back and from the start of how it develops, how to prove it, and how it works. Proving a theorem, like I say, it's the same all over. Like if you are proving a theorem, once you know how to prove a theorem, it repeats the very same way. You just say, I'm gonna construct this and this and this and this and this and that. You do have a textbook, right? Or
Yes, sir.
something, yes, sir, or something of that form where you uh, uh, um do you have a section which is showing how they introduced each and every theorem, or should we go through it? Because I wanted you to go through it first, and then we discuss it when you have done it, like Hanya.
Okay.
Okay. Just to familiarize yourself. I want you to see Hore, for your final exam, there's always gonna be one theorem that you would have to prove, and you would have like around 7 theorems probably for your curriculum that you may have to know, of which you don't know which one is gonna come out. So each theorem, they can turn the object into 2 or 3 different forms, but it still explains the same thing. It's just to know who I construct something like this and then I say this. But now we can't, like one of the things that I'm trying to be honest, name. Let's sometimes this is me now talking too much, being that person who talks too much. Sometimes we should try to understand, Hore, if we do things the way we did in the past, and in the past they got us here, we shouldn't be we should be flexible to the change, and the change would be the works on works off approach. Mr. Miyagi, because like there's a reason why I feel like if we can do this first, it's gonna lead us here, because I don't want us to have a lesson where it's just trying to solve questions, trying to find the reason why. I would like us to create that scenario that we sometimes talk about, the one where we are creating a basis of self-dependency of thinking without having to say this is this chapter, I must follow these rules, but having to say I'm confidently sure I can approach any questions because I know how things connect from one to another. I don't know if you get where I'm going with this. Yes, no, maybe, but
Oh, yes.
oh yes, yeah, I hope, because The goal is just to, and remember, we are not in a rush to anything. We are not writing anything tomorrow. We are just learning, and there's no rush to can be in something else while the one in the past is like the very same thing. There's no need to rush the chicken while you haven't finished the pap and the gravy. that's, that's the story. So now, let's look at this. Suppose we had to find O2 now. Let's improvise. O2. How do you think we can improvise this one from the information that we have? So far, we know angle D is 55 degrees. Using all the knowledge that we know, given that being wrong is not a crime.
If the way I'd make it out, it would be very long.
And how would that be? You can
Oh
explain
wait,
to
never
me.
mind. I'd say angle D1. No, D is equal to O1.
Angle D is equals
Wait,
to
what?
O1. When you say angle D is equals to O1, you are going back to saying DE is equals to OE, and we still don't have evidence of that.
Then I'm not sure.
Yes, we have, we have, we have this. So we have this theorem. This theorem it says that angle at center is twice the angle at the circumference formed here. So if this is x, this would be 2x. That's how it works when the angle is developed like that, by radiuses that are equal, and then they go up to join the points together. So the angle here happens to be double the angle there. That's just a theorem which we have to know also. Here on this question, we were supposed to prove this theorem, and it's just another story of telling you, hurry, you just have to know, hurry, in this part I'm gonna have to construct a line that goes like this, da 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 da, and then from there, it's another story. We'll discuss it when we get there. Mara, all in all, it's a theorem which you are proving, hurry, really, 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 angle at center is twice the angle that is formed at the circumference. So if you look at this shape now, you have to be able to allow your eyes to extract a structure like that, because they are just blinding you, but that structure is there.
Oh,
So these are the puzzles I'm telling you about. So you are able to see it with your own eyes. Oh, that angle. Then if this is 2 times this, therefore that means angle O2 will be 2 times 55, which will be 110. So you are using different theorems, like you are going around theorems over theorems over theorems. That's why I'm saying, let's go to analytical geometry, finish it, and then start each and every theorem that develops from it, and then finish it, and then come to this part. We're just gonna flow. We won't feel the need to. But anyway, let's finish up the remaining ones, just to show you what we are worried about is the same as what is happening at the back with because also the analytical geometry that you are doing, it's not really the one that you are familiar with grade in grade 10. This one, it has a bit of a high volume compared to that one. So meaning, as we need A students, bruh. I get we are not trying to guess and find a go exam. Mara, if I can try it, I can try. We need that confidence. Or I'm killing this all the time, which is, which is the only approach to that is to follow Mr. Miyagi's works on, works off. But yeah. Anyway, E2. E2 shouldn't be a problem now. Ne? Let's improvise again. Let me remove everything so you can see where is E2. So now let's fill up what we have so far. You have 55 degrees here. You have 110 degrees here. Yeah. And now you have to find E2 for 2 marks. I'm gonna allow you to think. I have good news. You know what's the good news? We no longer have to wait for 40 minutes for meetings. We just have to
Oh,
listen until we finish what we plan to do. Yes. So at least let's just do up to number D. Then maybe, just maybe, you would understand that we can start from question 3 because now we're in question 9 and question 3, 4, 5. Because we're going to pass some in between. We're going to pass trigonometry to come to this part. It's not like we're going to go through trigo. I just want us to do the other part, intro, one theorem at a time, and then after we have gymmed, and then these things are just gonna flow. But I just wanna see, E2 shouldn't be that hard. Just think properly.
is
Finding E2 shouldn't
E2
be that.
20 degrees?
How so?
I just used exterior angle and interior angles.
So you said um, you said H2 plus E2 is equals to 110. That's what it had. That's what it said.
Yes.
I'm not sure. I feel like just saying yes because I'm not sure. I'm defeated now because I feel like that yes, you know what, Ilahori, let's just get it over and done with. But Bona, ne? Already if you know O1, you automatically know. I mean, if you know O2, you automatically know O1 because they're angles in a straight line.
Yes.
And then this one is 90 degrees. So you have angles in a triangle with one unknown, which is E2. It could be 20 for real. That's why I'm saying, which angle did you use?
The 90, and then oh, oh, one would be 70 degrees.
Yes. Yes. So yeah, it is 20. So that's how I was just confirming the angles that you use. But now, you see now it's getting to connect to some of the stuff that now has nothing to do with the theorem. Now it goes back to a normal triangle, the way you would work out a normal triangle. And then the last one should be the size of E3. 3 marks. Where do we start on this one?
Yes, I'm not sure.
Like, you know what? Manipulate your mind. Hanya. Manipulate. I'm gonna give you a hint. This is my hint. Isosceles triangle. isosceles triangle. I gave you the answer, Joe. I just put the answer in your face.
Point 50 degrees.
Isosceles triangle. No, like the important thing is not the answer, just the steps. The important thing is not an answer. You could be right, it could be 50 degrees, but the important thing is not the answer. How do you get the 50 degrees? Statement, reason. So, let's go with it. What was your first, towards your 50 degrees, what did you think of first? So we are writing the first statement and the 3 marks. What is our first statement towards getting A3? You say it, I write it.
E plus G plus F is equal to 180.
E plus G plus F is equals to 180. The full everything.
Yes.
Sum of angles in the triangle, ne?
Mm-hmm.
Okay. But that information diverse. Mara, let me see how you break it down. And then next step.
So then I said 55
Uh-huh.
plus 55.
But we said E plus G plus F. How is how is okay? How is E 55?
Oh, I meant G.
So G is 55. Only G is 55. We don't know
G
what
and the
F
sum
is.
of F is 55.
No, we can't say that because we only have. What is the reason for that? Because we are not sure if EG and EF are equal.
Oh.
We can't say that. But that rule that you are using, why don't you apply that on triangle OFE? Because the angle in question is E3, bruh. Why go so far?
Oh.
Because what the exact thing that you are saying on that big triangle, say it on that small triangle, which is OFE. Let's try that. Let's try it again. The very same thing you are saying, but try it inside OFE. Because already you are 100% sure that OE is equals to OF because they are both radiuses. Meaning angle E3 is going to be equals to angle F1. So you can just say F1 plus, okay, why do I say E1 now? E3 plus F1 plus O2 is equals to 108. Same thing that you said, but in a different triangle. Sum of angles in a triangle are equals to 108. That's the reason. Now I'm looking into this triangle. You see? And I'm happy because the two angles are equal. Since they are equal, it will be x plus 110. I mean plus 110 is equals to 108 because I know that O2 is 110, right?
Mm.
Therefore, because they are equal, 2x plus 110 is equals to 108. Therefore, 2x is going to be 108 minus 110. Therefore, 2x is going to be, you can work it out from here, 108 minus 110, 8, ne? 60.
So 35 for X.
Yes, so it will be 70 and then yes. is 35 degrees. So the concept is just to, like, there's no other way, bro. Like the things that we do inside the circle, they are the things that we do in the very same triangles that we start with. Nothing changes. It's just that now they are considering it a circle. To be honest, it has been a circle. Everything has been about the circle. It's just that we don't say it because we don't want to block your mind from understanding things. Or maybe if we could have said it earlier, it was going to help you more. But it has been a circle. Think about this. Why do we use Pythagoras when we're doing trigonometry that time on those triangles when we could have x and y and r? And why does it rotate throughout in angles, but it ends up forming triangles everywhere? It's been about circles throughout. Like there's always a circle involved. We just ignore it at some point in other Cartesian planes. Mara, all shapes happen at the same time. Like that's why in circle now we have chords, we have radiuses, we have tangents. All those things is just circles and squares and waves, and it's just different shapes. But in another world, in another dimension, they all happen in the same time. So don't think of it as like I know the eager of feeling like H2. I feel like at least I know a bit of this, but I need to unlock more knowledge because I'm getting behind, and the year is getting in, and I'm getting behind, and I'm not understanding anything. Rather, you understand 50% of what you know with confidence and not know the other 50% and go right and get 50% yeah total yeah what you know and pass instead of going there, like approach your pizza, like you just know a bit of that, a bit of that, and a bit of that, and hoping to combine it together to get you to 60%. Like this time around, we are approaching this, and the Mr. Miyagi way is the one which I'm saying. At the same time, we are also mastering how to answer these questions in a question paper. Hence I always say to you, it's not about the answer. No, like you should. I don't know how to say it, but you should learn not to care about E2 is 35 degrees. You should learn to care about the part here. E3 plus F1 plus O2 is equals to 180, because once you know that part already, your maths is at the level of you can find that E2 is equals to 35 degrees as long as you know the first step. Or when. So let's not rush the end. Let's not rush the final answer. Like the final answer doesn't matter. Even if you didn't have a calculator, even if you can divide 70 by 2 wrong, but you would get at least all the marks, subtracting the one that you got the division of the last one wrong. But if you get the first step wrong, you won't even get to, you know. So I don't know, man. Like my my point being, I'm gonna repeat this all the time. But I know, like with me and you, the year goes like this. I'm aware, but sometimes the Mr. Miyagi way, bruh, works. Like let's follow. I know that's gonna, like, we can use this approach on days where you are writing tomorrow, where you can rush to do things how you would prefer them to be done. Mara, in terms of how we are trying to get I wish I could compare sometimes, and I know it's bad. I wish I could compare other marks of some students whom I could say 6 months they were here, now they were here, now they are here, because they just follow the Mr. Miyagi way until that day when they are writing, and then it's freedom of speech. But now, I'm not saying I'm against freedom of speech. I love freedom of speech, but in terms of the chapters, let's try to complete what we need before we can get to the other one, because to be honest, I feel like we are rushing circle geometry, and I feel like you are not ready for it. What do you think?
I think I first need to understand the theorems because, like, we haven't started with it.
Yes.
And then my teacher said we don't need to know analytical for the circle theorems that we're writing in June.
Okay, I understand. Look, but Yeah, yeah. I can put myself over the teacher's shoes, but I was just saying, it's not the analytical geometry is not. Unfortunately, I was not doing it for marks or for the
Mm.
test for June. I was using it as an introduction to make the circle geometry looks like it's a walkover. So there's a trick that I know personally, if we can do this part and do this part and do this part, it's gonna make this part easy. It's just a pathway that I feel like if we were to do an intro like this and then land here. So remember, Mara, I can't take away the fact that probably regardless of how people learn differently, Mara, I was using the fact that we do have time for now. We are not in a rush of June yet. I know June is gonna come soon, Mara. We do have time, and the only way where our time could be delayed it would be those days when you are busy or you feel tired. Mara, we do at least have time, and we still have time. The upcoming few days, we're gonna have holidays. We're gonna have time. We can, if we were to do the part that we are doing, it's not even going to take us more than 3 days to finish that part for us to can go smoothly to this part. It's not like something which you're going to do for 55 years, but it's just not happening because all the days that we could have done it in the past, one of us could have not had, like you see, like those time management that we always struggle from. But if we can at least finish this and then do the theorems and then thingy. But it's fine. Let's not. This is our argument for another day. Let's do this. Look into the theorems. I don't know when do you think you're gonna get time? Without, I don't want to rush and say do it da, 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 on this time tomorrow.
I think tomorrow and then also Thursday I'll look into it further.
All right. Look into the theorems. I will try to find some. I will send you images. Look into them. Be confident with how they work, and then we're gonna try to see where does it put us, and then we're gonna try to go through each one at a time and see. But every triangle, every knowledge you know about quadrilaterals, it just comes back to reality and play a role. Just that this time around they put it inside a circle. Just because it is inside a circle, it doesn't mean all the other rules that you know they don't apply anymore. So with that being said, I think we can call it a day, ne?
Yep.
All right. So for now, I'm gonna depend on you looking into those things. But anytime, if you, I know this is Mampara week. Any student is not into, like, I'm just getting voice notes here and there. But I know everyone is just on some, we are tired, we are just resting because we've been, and is that week where you are closing this week, ne?
Yes. On Friday.
On Friday. All right. I know it's fine. I think we're gonna use those. I know that sometimes the holidays, guys, I was saying for the holidays, without even making it like, for you guys who are grade 11, you shouldn't be stressed about having a lesson yana once every day on your holidays just to keep up the momentum. Do you think that would be a problem?
No.
It's not. Like, just because I feel like there are some, because I'm like, we've been having, some people they just want to rest. Mara, for a grade 11, grade 12, you're at a state where I think even you yourself during that week, nyana, you would be studying your own things anyway. So if I can steal your hour nyana for a day, we could have been doing mathematics or physics, which for that day you wouldn't even have done yourself. So at least you would have like pushed nyana. So we can use it as our time to catch up, just every now and then, I guess. And I got guys in a good way. Like, sometimes I look like I'm the one who doesn't have a life. Linda, I wish I could, I wish I could just chill and watch series all day and just eat popcorn and not do anything. But the commitments they have to happen. So at least it gets it gets nicer when we end up meeting, even though it's hard. The worst one is when I come and sit here and wait, like wait and wait and wait and like
Oh
maybe the
yeah.
next 5 minutes, maybe the next 5 minutes, and then I end up feeling like, "Ish, I could have done maybe something important with that." But anyway, now that I've fixed I'm trying to improve my things to a point where I'm trying to get to, I don't know if it's gonna work, because if the one where I communicate directly and say let's meet now, it doesn't work, I wonder if I can put a schedule on Google Classroom and I said 3:30, go press there, let's meet. Do you think you guys, you would be able to be responsible for that?
Yes.
Yes. I'm just trying it up because I'm trying everything I can, bruh. Because I'm trying to come up with a way where people are free to can have like their own, so we can arrange weekly. Or I mean, on this week I would like Wednesday, da 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 da, and then we say in the schedule. But I'm gonna still put the other ones for the groups because those ones they have to keep on happy. Actually, for me, I'm not killing any students. For those who want, if it was for me, every day there should have been a lesson. Like for more especially for the group ones, like every day that one should be consistent where we can look at it as we can answer question papers all the time. We do question one now, question one, da da da, finish question paper, do another one while we have our own one on ones on the side. Dude, that would take us far. But hence I say there are other people who are following to that, and I feel like I saw, I saw this. It was a picture. I saw it on social media where this other teacher in a public school. You know what he does when they write exams? He displays their marks on a window. Or this one performed better than this. Is that good? Do you think? Would you like that? Would you settle for that?
Yeah.
Yeah. Because I feel like it's not fair to display other people. Like you can we don't live in a life where you can compare marks and say position one, position two. No, I'm not saying I'm gonna do that. I wouldn't do that, Mina. I don't have a right to do that. Remember, I'm not as cool. I'm just facilitating. But there are other people whereby they celebrate like, hey, look how well I did, and I'm like, yeah. But when I compare as to the commitment, I'm like, oh, da, 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 da. It's just those analysis that I do by myself, and we can only push the encouragement like, try to. But Oksalayo Joe, it's not easy for everyone, and I also accept the fact that people don't think the same, and then they don't look at these things the same. But you can tell who there are other people who try to put more time than others, and it's just life. Maybe we don't have the same uh, commitments when coming to other things because our lives are not the same. Other people probably they don't even have lives. All they do is just it's just sit on the physics, right? But anyway, cheers, man. Enjoy the rest of your evening until we talk again. I'll hear from you, ne?